Desk Talk by Gamma, keeping you connected and protected.
Welcome to DAS Talk, the essential podcast on distributed antenna systems and in-building communication, hosted by Peter, VP of Gamma, and Philip Nicholas. This Gamma Electronics series focuses on emergency response and safety. Join us as we navigate the challenges of building effective communication systems for North America's first responders. We delve into the advancements in emergency responder radio systems and the transformative impact on new technologies. Tune in for insightful discussions aimed at increasing knowledge and awareness in the DAS field. Whether you're a professional or an enthusiast, DAS Talk is your gateway to understanding the nexus of technology, safety, and communication.
Hey everybody, welcome to DAS Talk. You have Philip Nicholas here with my co-host, Vice President of Gamma, Peter. How are you, man?
I'm awesome. How are you doing?
Good. I'm doing good. I'm ready for this interview. I'm kind of excited when this jumped on our desk. So let's get this started. So I'll let you introduce Tom from Honeywell.
Yep.
Let's do it.
Awesome. We've got Tom Warfield from Honeywell. He's likes to call himself the training manager, but his official title is Senior Application System Sales Engineer. But he said that his specialty really is to get in front of people and teach and train them basically how to do BDA systems with Honeywell. So Tom has been in the RF electronics industry for just a little bit of time here. He's got quite the extensive background, basically since graduation. Tom's first position was an electronics technician for companies that manufactured surveillance receivers in the military. He taught associate's degree program in electronics at ITT Technical Institute. He held RF engineer positions in commercial cellular industry with both Nortel and Verizon Wireless. At PCTEL, received invaluable field experience in the IDAS and ODAS fields, performing commissioning, CW testing, and drive testing. For the last 5 years, he's combining his knowledge and love for teaching as a training manager, delivering certification classes, both instructor-led and online with Solid and currently 5-plex Honeywell. He's a contributor to Safer Building Coalitions, in particular the complete ERCES handbook with NICET in Building Public Safety Communications study guide. He has received NICET IBPSC certificates levels 1, 2, and yes, 3 as well, all 3, and designer as well. So this book we'll kind of touch on later, but he was a contributing factor to this book right here, which is quite the beast of a book. So with that said, Tom, tell us a little bit about you, your background, and how you kind of got into all this RF stuff that you seem to have such a great passion for.
Well, it's kind of funny. I actually kind of stumbled into it. My real love when I was younger was audio engineering. And I wanted to be in the recording studio. And I found out that either you're a gopher or you're not in it when you start out. And someone recommended that I learn electronics and I could get into recording studios as a technician. So I got my electronics background, associate degree at the time. And my first job offer was with that company you mentioned, that made military receivers. And it was a pretty good job offer. So I said, well, let me do that until the audio thing comes around. And long story short, the audio thing never came around. So I was in RF from the very beginning and pretty much stayed that way one way or the other. And the only time was when I was with that ITT Tech, and I was teaching all forms of electronics at that time. But I got into RF, really liked it. It was a very diverse field, and it's done me well over the years.
It's interesting how that works, just like in general, where like you think you're going to go this way with your professional career in life, and well, I'll just pick up this job because the job kind of fell in your lap. Maybe it was a great job offer and you were just like, that sounds good. I'll try that out. And then all of a sudden it ends up being your career for the rest of your life.
Yeah.
I mean, it's pretty kind of cool how that works out. And
it happens all the time. When I was the training manager at Solid, which curtailed more to the Verizon, T-Mobile, AT&T engineers, I would ask people, said, did anyone here take a college course or anything to become an engineer? And it was a rare day. Almost everybody stumbled into it one way or the other. Most people have not gone to college for it, maybe some military background, but
Mhm.
uh, really not much. Everybody just has a friend who has a friend, and they just found themselves in the industry.
Yeah, that's a lot how this works. So I know you've got a lot of experience in emergency responder communication systems, right? In ERCs and so on. And it seems like your background at Verizon and your background at Solid kind of like brought you to your point where you're at right now. What's your passion about this? Why? I mean, you travel every other week to do
Yes.
training, and tell us about your training, but tell us about your passion, about what gets you going. Why'd you stick with it, and why are you where you are?
Yeah. So when I was with Verizon, Nortel, and a lot of it with Solid, like I mentioned, it was all on the commercial cellular side.
Mhm. Yeah.
And I got to know that side very well. And then the opportunity came to uh, got an offer from Fiplex, and at the time I didn't even know who Fiplex was, and
Oh.
at the time, and so I looked into it and I said, yeah, this is expand my career, expand my knowledge, because it's even though it's RF, and a lot of people say RF is RF is RF, there's a lot of differences, and I wanted to explore how it could be made better. Sometimes I like to call myself Mr. Uplink because I see a lot of emphasis on downlink. Uplink is kind of a mystery. And at Verizon, Nortel, and Solid, we talked a lot about optimizing uplink. And so when I started at Fiplex, I pretty much asked a general question to a bunch of RF engineers who have been in the industry. I say, how is uplink optimization done in the public safety side? And honestly, I got a bunch of crickets. It's either calculated, maybe they do a delivered audio quality test,
Okay.
maybe there's some calculations, but there's a lot of assumptions made, and that's one thing I wanted to fix because, as you know, and as the Safer Buildings Coalition points out, is the BDA industry does not have necessarily a sterling reputation when it comes to causing maybe some noise and interference, and that's all uplink. It's all uplink. And that's kind of my passion, and what I like to talk about is how do settings affect the uplink, and how can we set them up so that it works but causes the least amount of interference. And so that's really what I've been working on.
So you made a pivot. You were doing broadband
Yes.
applications, and which ironically is also sort of my background. I came from broadband, doing a lot of broadband stuff, and so is Gamma. And then we also made a pivot in recent history to go in building, and then the safer building ERCs, and there was all this synergy. Yet it's different, but I love it. I really do. Kind of like how you're saying right there. And so, is that what you do? You like the in building better then? Do you enjoy it? Do you enjoy it a little bit
Well,
more?
yeah. Well, let's just say that I consider myself in building for both cellular and public
Okay.
safety.
Okay.
And yeah, it's just another kind of a challenge.
Hmm.
In what I was doing is a lot of what I would call closed systems, where the solid systems did not work with over-the-air signals. It was all generated by base stations, at the site,
Hmm.
directly plugged into the DAS system. And public safety, it's just the opposite. It's mostly over the air, and so that's a whole nother can of worms when it comes to optimization. And then you have public safety is full power or off, and cellular is always adjusting itself for the lowest output power that it can, but
Hmm.
it's a closed loop. And I see people going from the cellular industry over to public safety and not realizing, those little nuances between the systems. And that's one thing that we need to point out is, you know, how they work together.
So help me out for a guy who comes, who doesn't know really what the difference between uplink and downlink is. So there's uplink and downlink on your cellular system that you brought up, and then also on your first responder BDA systems, right? So there's uplink and downlink. So let's since we're focusing on RCs right now, why is that so important that there's a good uplink? And what's the first of all, what's the difference between an uplink and a downlink? And then why is the uplink so important?
Well, it's important for both cellular and public safety. Let me just first define it. So, sorry, I didn't define it first. But I picture we have both cellular and public safety is obviously a two-way communication. We have it from the tower to the walkie-talkie, and then from the walkie-talkie back to the tower. And what I like to tell people is almost always the tower is the tallest structure around, usually on a hill. And when it transmits a signal, it almost always goes down towards the walkie-talkie. So we call that downlink. And then when you hit push to talk on the walkie-talkie, the signal almost always goes up to the antennas on top of the tower. So we call that uplink. So downlink and uplink just describe the different directions. Mm-hmm. And other terms are used like transmit and receive. A lot of jurisdictions like to use those terms, but they're looking at it from the tower's perspective. Like transmit is what the tower does, and the walkie-talkie is what the radio does. But if you're Motorola and you're making a handset, transmit is the opposite direction because it's going from the handset back to the tower. Mm-hmm. So we like to use uplink and downlink rather than transmit and receive, but overall about the same thing. And the reason it's important is you get a design software like IBWave or RANPlan, and you look at people's designs, and you usually get a packet, and you look at the packet, and they say, all right, this is the downlink coverage, and this is the downlink signal-to-noise ratio, and this is blah, blah, blah. It's all downlink. But the truth of the matter is downlink could be excellent, but if an uplink doesn't make it back to the tower, then the system doesn't work. It doesn't matter how good the downlink is if the walkie-talkie can't reach back to the tower.
So how does that impact the first responder if he can hear, but he can't say anything, but could he think that his message is going through and it's really not?
Yeah, he could think that. And there's different ways it manifests itself. But along with teaching people how to use our BDAs, we also do classes for AHJs and building owners. And when I do get a bunch of AHJs, which are almost always old, they're first responders in their old days, mm-hmm. Now I always ask the question: have you ever had a radio not work in a building? And almost everybody says, yeah. There's been several instances where it didn't work. And then I would ask them, what was the problem? Was the problem is that you could hear the dispatcher, but the dispatcher couldn't hear you, or the dispatcher could hear you and you couldn't hear them, or didn't work at all? And overwhelmingly, the majority of the people say that they could hear the dispatcher, but when they tried to communicate their situation back to the tower, that's where it failed.
And that's critical because this is where they are. They're in that environment, right? So it could be in a tough situation, whether they're, law enforcement, whether they're fire, or whether they're EMS. That's kind of irrelevant because it could be an emergency no matter what, but they've got to be able to communicate what's going on.
Yeah. That's why I say when I'm in the cellular world, and I tell people, they go into a building and your cell phone doesn't work, it's an inconvenience. But when a first responder goes into a building and it doesn't work, that could be life changing. So it's critical that it works in both directions.
So in most instances, okay, so there's two things that I'll dive into with it. In most instances, what's causing the disconnect? So I got a walkie-talkie. I can hear the dispatch, no problem, right? So he's telling me this is the situation. You've got to go to this part of the building, or you have to go to this room in this hotel. You have to find these people and see what's going on, right? And I'm saying things back to them and they can't hear me, right? And I know, for a novice guy, there's little antennas all over the place inside this building that are supposed to be grabbing my signal and sending it to the bidirectional amplifier that's magnifying it and sending it back up through the donor antenna on the roof back to the tower. Why is it I can hear and I can't send? What do you think the primary cause for that is?
Yeah.
Is that a loaded question?
Well, man, there's a lot of things, but let's
Okay.
talk about a building first of all without well, I call it IRCs or IRCs,
Oh,
whatever you want to call
okay.
it.
All right.
The basic problem is a math formula called a link budget, and basically what the link budget is this is the output power of the transmitter,
Mhm.
and then there's gains and losses, and eventually that power reaches the receiver. So it begins at the transmitter, ends at the receiver, and just looking at it, if everything is equal, the transmitter on the tower side has way more power than the battery operated walkie-talkie going the uplink direction. So there's a power of transmission imbalance right from the very beginning. Now, a lot of Motorola's and the Harris's that design the system themselves, they know that. And so the tower can have maybe some help on the uplink side, like higher gain antennas for receive and tower top amplifiers or TTAs, which help with the uplink as well. But so it doesn't have to be that the uplink loses power before the downlink, but it just seems like often enough that's the case.
Mm-hmm. Which makes sense, right? I mean, you got
Yeah,
a huge power imbalance, right? So you've got a
yeah,
tower that's hardwired in, right? So they've got as much power as they need, but you've got a radio that's only powered by batteries, right? And
right.
those batteries are not all created equal either, right? So
Yeah, and that's the thing is the walkie-talkies, if you have a fully charged battery, they'll put out so much power, let's say
Mhm.
34 dBm. But as the battery gets weaker and weaker and weaker, the walkie-talkie is kind of smart enough that the battery's about ready to run out. So how can we save some energy? And it'll reduce the output power when the battery is getting lower, so that the battery lasts a little bit longer. So even the power coming out of the walkie-talkie is not necessarily a given value. It can get less and less as the battery gets weaker.
that's
And then
that's
yeah,
challenging for a system, right? I mean, if the uplink sending signal becomes lessened over time, then your system needs to be able to accommodate for that.
right. So that's the problem. Let's just say from the macro world, just
Yes.
and then if you throw in an in-building ERC systems, then this is where it comes back to the designers. The designers just can't design for downlink coverage. They also need to design for uplink coverage. And in the public safety world, what we have is that near far effect,
Mm-hmm.
where you have two first responders, one fairly close to an antenna, one fairly far away from an antenna, and that guy that's near, when he hits push to talk, the BDA sees a strong signal and it lowers its gain, and it lowers the gain too much so that the far hand side, if they hit push to talk at the same time, it can no longer reach the tower. And the answer to that is there's a couple different ways of fixing that, but at the most basic level is to make sure you're never too far away from an antenna by having more antennas. And
But
that's something that,
that's a common thing that happens though in designs, right? And also to save a little bit of cost, right? Because you've got less cable, less connectors, and fewer antennas, and the less you have, the lower the cost of the system is.
yeah,
That's kind of innately kind of an issue because you could have a proposal that came before someone, and a building owner may not know the difference, right? And he's like, "Oh, this one's quite a bit less."
mm-hmm.
Oh, well, you only need X amount of antennas and cable for this build, but the other designer might be taking into consideration the uplink while one is not or not as much. And now you've got a price war, but the systems aren't the same.
Yeah. And that's, man, I don't know the answer to that because we all know that a lot of times ultimately it comes down to the dollar. And
Yeah.
and unfortunately, how people prove that this system works is often by a downlink plot saying, listen, if we put only these few antennas in there, the downlink is going to be significant. I mean, it's going to meet all the requirements.
Mm-hmm.
Now the code says that, the requirements have to be the same going, back to the tower, but most of us don't have access to the tower. We can't measure it. And like that near far effect, that's most people don't test for that or even know. I mean, like IB Wave, you can plot it, but most designers don't nowadays. That would be one thing I would encourage designers to do, is look at the uplink as well, and the near far. And what makes it even harder is that not all BDAs are created equal. A lot of people see the red box in the wall, and it doesn't matter the brand name on it, but they all have, different characteristics as far as how much gain range do they have, and it's tough. And what makes it even worse is Class B BDAs and some Class A BDAs. Do you want me to stop and explain that to the?
Yes, please. Go ahead.
Yeah.
Yep.
So the easiest way is what's considered a Class A BDA is one that we'll just say is channelized, and that you program the specific frequencies coming from the tower, you amplify those frequencies, and you ignore everything else. And a Class B BDA, you just put in one big filter that allows the lowest frequency through the highest frequency through, and it's just one filter. The FCC has a slightly different definition of that, but for the most part, that's what most people use. And what happens is a Class A, if you have a near handset, it will lower the gain for that frequency. And then you have a far handset, it will raise the gain of that handset completely independently, because each one is in a different filter. But with Class B, there's only one gain because it's just one filter. And so if you have a near handset, it lowers the gain, and you can't have a separate gain for the far handset because it's all the same amplifier. And I asked designers, hey, designers, when you're designing, do you know if you're going to put a Class A in or a Class B? And often they don't know. And it makes a difference. If you have a Class B BDA, you should have 20 to 30% more antennas than if you have a Class A. But a lot of times the designers don't even know to ask the question, to be honest.
So they need to be taking that, and that's a big deal. They need to take that into consideration.
Yeah.
So Class B equals more antennas, Class A equals less.
Mm-hmm. Yeah, theoretically, yeah. And it's back to your original question. Let's say there is a BDA system in and uplink's not working. It could be very well that when the BDA was tested, most of the time the AHJ comes in and they have their handsets and they do what I like to call the "Can you hear me now?" test. They hit push to talk, and if the dispatcher hears them and the dispatcher can call back to them, well, everything seems to be working. And especially with Class B BDAs, that might be true. But if you have some sort of emergency, like active shooter or something like that, and you have all the first responders in there, what happens is if one person hits push to talk, they get full power on the uplink. But if there's two first responders hitting push to talk at the same time, they each get half power. And if you have 4 first responders hitting push to talk at the same time, they each get a quarter of the power. And so what happens is that the BDA appears to work just fine when tested with one person. But if you have a major emergency, all of a sudden the BDA doesn't get back to the tower because that uplink power is being shared by everybody that's sitting push to talk at the same time. And that's called a power derating. It's like, what's the worst condition? And most jurisdictions don't know to test that.
Yeah, I was actually gonna touch on that because from my experience, I was at Safer Building Coalition in Mahwah, New Jersey last year. And some of the AHJs are really, you can tell they're really into it, and some are very new to it. And a lot of these guys come from a background where they were a fireman and they moved up in the ranks, and then they became chief. And now all of a sudden they're like, by the way, you need to test and verify these systems, these RF systems that are rather complex. And some of these guys are really, really struggling on how to do that. And RF is not their thing. It's just not their thing.
Yeah.
and I empathize with them. And one of the AHJ, which is an authority having jurisdiction, and they're usually fired on what jurisdiction, how big it is. He came out of the room and he was almost in tears about how frustrating he was because he had no idea what was going on. And he was like, I don't know what I'm going to do. I don't know how to test. So you brought up the point where, can you hear me now? Can you hear me now? Test. I was going to ask you, is that normally how most jurisdictions are testing their uplink? Can you hear me now? And if that's the case, what should they be doing to not use the what do they need to be doing to not use the can you hear me now test with their two-way radio?
Yeah. So first of all, let me just tell you that, the AHJs, to your point, have been put in what I almost consider an impossible situation.
Yeah.
And it goes back to the national, the IFC and the NFPA national code saying the AHJ will do this, this, and this. And honestly, they're all very nice people. They all, they're smart people. It's just that, they just don't have the background to do that like a radio person would. And it's
kind of not fair. I mean,
no. And
yeah.
And to the Safer Buildings, coalition point is you have this license holder, which theoretically does know this kind of stuff. Though there are some out there that don't, but let's just say that they do. They're the ones who actually should be doing the testing. And the AHJ, come on out and look at the electrical, look at the physical stuff. But when it comes time to actually test the system, most of them are ill prepared for it, and don't know the nuances like the ones I just described. Is just doing a "Can you hear me now?" test may give you the false illusion that everything is working fine.
And rarely is it do you have one first responder in a building. It's always a team.
Yeah.
Always. And
so
a lot
tough.
of times they are in different locations, right?
Yeah.
I mean, depending on what service they're providing.
Yeah. And so, first of all, I am a big believer in doing an audio test no matter what.
Sure.
Even though I'm a test guy and I did work for PCTEL and love their scanners or any of the ones that do the same thing. You can make all the measurements in the world and have a whole bunch of confidence that it's working. But until you actually hit that push to talk button and hear it work, it gives you that final yes, everything is good. And we've seen that in the codes where the code started at minus 95 dBm. That's the pass fail, and then all of a sudden it's like, oh, we can have signal strength that's good, and it still doesn't work. And that's because the quality of the signal is not looked at, or especially with digital systems, any kind of propagation delay, any kind of delay through the system causes issues. And the problem is that a lot of times the codes try to break down a radio system to one number, and either that number passes or it fails. And at the end of the day, that's just a fallacy. It's never going to happen. You just can't test a radio system with one number and say, yes, it works, or no, it doesn't, because of all the different situations. So whether it's a minus 95 dBm or a DAQ of 3, or I've seen jurors, like I was in Denver the other week, they want a bit error rate of 2.6% or lower. I think that's the number. Still just trying to get it down to one number. And I can take any one number and show you a situation where a second number will tell you you're in trouble. And it's you really need to have radio guys understanding everything. And so AHJs, it's tough.
So it sounds like to me they have to rely upon, frankly, the integrator in many instances.
Yes.
Because the integrator, they are trained radio guys. They know how to use the test equipment. They know how to pull the cable, install the system. Yet they've not always, but it sounds like in many instances they're probably going to know more about these systems than the guys who's supposed to tell them that the system is passing.
Yeah.
Right. So I can see that being kind of a challenge in the industry a little bit. And sometimes maybe they're overreaching and asking for things that aren't really too relevant to the system.
Well,
that I could see that happening too. And maybe they're interpreting code a little bit different. I mean, you've got thousands of jurisdictions, some dozens right around New York City alone, and you've got different levels of experience of people who are inspecting and verifying these systems. And you've got these massive buildings popping up in what were once small jurisdictions, and guys who are like, hey, I'm a fireman.
Yeah.
You know, and now you're talking about DAQ, you're talking about signal to noise ratio, you're telling me, I can't just hit, push and play and my system works just fine. What are you talking about, Tom?
Yeah.
Come on
Yeah.
now.
I know. It's amazing.
Yeah.
It's to say that education is needed all around is the biggest understatement that I could make. I mean, I look at all the stakeholders. Do the AHJs need more education? Absolutely. Again, like you just said, there's some AHJs that are going like a bull through a china shop and almost trying to make it gold plated, and they're going too far. Trying to make it so this system will never fail. But when they do that, they're putting a whole bunch of costs on the building owner that is kind of unfair to them. And then you have the AHJs that, like you said, just are coming in knowing nothing. It's just a wide range. You have the building owners that, I don't know how many times I hear stories where the fire marshal comes in for their final inspection and they say, show me the report for the IWCEs, did it pass or fail? And everybody shrugs, what are you talking about? I mean, they don't even know that, the test needs to be done until till right near the very end, and they're completely caught off guard.
So let's talk about that for a second.
Yeah.
Okay, if we could. This is a story that I can't tell you how many times I've heard. And again, like you're talking about. So they want to get a building owner wants to get a certification of occupancy, right? So he's done everything so far as he knows. And then he goes to get his cert, and they're like, where's your report for your IWCEs, like you're talking about, or your IWCEs? And they're like, huh? I mean, there's got to be a disconnect here. I mean, because that's a big problem. And I mean, because these systems need pathways that are built into the building. Okay, they need areas where they're going to put your amplifiers, your bidirectional amplifiers, and store your cable. They need to be in rooms that have sort of 2-hour fire rated enclosures and so on, that are protecting the backbone of the system versus the distribution side, right? So if I'm coming at that and I don't know, if I haven't designed that in, how problematic is that? How much of a problem is that?
That's a big problem. It's going to cost a heck of a lot more to fix it at the end than to have built it in at the very beginning. And we teach not as much as we probably should, but architects and engineers, and to tell them what the code requirements are, and that whole fire rated business, which is it's a whole nother can of worms. I mean, as far as what the fire rating needs to be.
Yep.
But having the provisions for it, even just we're even encouraging people to run the coax cable during construction, even if the building doesn't need it. And that's what we tell the general contractor or the building owner, that we could put all this kind of stuff in for this price, something like this right now while the building's being constructed. And I can't even tell you if we're going to need it, because we can't really do the test until the building is like 90% done. And so 90% comes, and maybe it was money thrown away because it doesn't need it. But if it does need it and we didn't put it in, it's going to cost you this much. It's what do you want to do? It's a little bit of a gamble one way or the other. But then you throw in the fact that the building needs to be recertified every 5 years. So maybe it doesn't need it on day one, but 5 years from now, someone builds a skyscraper right next to the building, and also now it does need it. If they,
that's gotta hurt someone. They're like, oh, my building passed no problem, right?
Yeah.
Built an apartment building, right? And you're like, for whatever reason, it just signals great. They can talk. Firemen can communicate. Even cell signal goes through. And that plot of land right next door was sold, and 2 years later, before you know it, you've got this huge obstruction in front of you. So you have no range to the tower. You can't communicate at all. And then you get inspected and they're like, bam, you need a system now.
Yeah.
You're like, how much is that going to cost me? And it probably blows their mind when something like that could hit, right?
Yeah.
And what are the repercussions if they don't get that system? Like if they're like, well, no, when I built the building, I didn't need it. How much teeth do the fire marshals have?
Honestly, that's a great question. I've never considered it. I mean, I don't think they would revoke the certificate of occupancy, would they? I don't know. Maybe a fine? I don't really know the answer to that.
Maybe my next guest needs to be a guy who can tell me I have to revoke him. Or not. I don't know. It's just something that came into mind while we were talking.
Yeah. No, I don't know.
So you touched on something. The biggest challenge you feel like in the industry as a whole is education and training, it sounds like, right? I mean, those two kind of things, education from the different stakeholders and then the training involved. So you've got nice set levels 1, 2, and 3, a PSC certificate. Can you tell me just a little bit about that, the difference between the levels, and maybe touch on, let's just say I am a fire guy and I'm really interested in doing this because there's a lot of business there, fire alarm guy, and I want to go through this certification so I can do this properly. Tell me what's the investment and how difficult is it to get the NICETs?
Yeah, well, first of all, as anyone who has any other NICET certifications knows, it's more than just knowledge. It's also practical experience.
Okay.
I mean, you can pass the test. You get 100% on that test, and you may not get the certificate if you've never done anything in the industry. So experience is just as highly valued with NICET as knowledge in the brain. So you do need to have that practical experience. And for someone just getting into it, most of them are we'll say the cable pullers, the combiners, the splitters, and the antennas. But they install those without really knowing how it all works. They're just running the cables through the buildings. And that's pretty much, we'll say, level 1. Okay. Level 1 is to make sure, you understand that, a kink in the cable is not just a cosmetic thing. It can actually cause a problem with the signal, and best practices for that. A lot of questions on grounding techniques. Overall, we're putting a metal antenna on the roof. We better have some surge protection and grounding understood fairly well for that. And then level 2 starts talking more about not just doing what your supervisor says, but actually understanding the drawings and how to a little bit more self-sufficient, that you can install the passive system on your own by just looking at drawings and not just being told what you're doing. So level 2 is just a little bit more self-sufficient.
Okay.
And then when you get to level 3, that's the programming or the commissioning of the BDAs, and that's where the math and the RF knowledge really starts to be questioned. What is a DB? What is it? How do you do path loss through the air? And all those kind of questions is be the level 3. So basically you see a lot of level 1s and level 2s installing the entire system, but not logging into it to set it up. And that would be the level 3.
So it seems like there will be a lot of people who will install the system, and then maybe they'll have somebody else come out who's better trained. Sort of verify that the system is doing well. I've seen that pretty commonplace, because maybe they don't have the NICET 3 certification in their own staff, and they might have designers who also design the system for them, and they'll pull the cable and install the cable. Now, if there's a jurisdiction and the AHJ hasn't required NICET for the integrator just yet, it sounds to me like it might be a really good idea to get on this and start getting your guys and you as an integrator NICET certified, so that you jump in advance before that kind of becomes a requirement. Is it going to become a requirement to install, you think, maybe eventually, or what?
Yeah, we think it is. Some jurisdictions are already kind of putting it into their requirements. Now it's not like you don't need it today, but you need it tomorrow. They're giving like a year or two. Again, because of that, NICE, it needs like 6 months, a year of experience. So it may not be something you can get tomorrow. You might have to wait that 6 months to get it. And I think most of the people that are putting in the requirements realize that. But there's already a couple of jurisdictions that are already say we're going to make NICE it a requirement.
Oh, wow.
And,
Okay.
yeah. So yes, and we definitely think it shows a level of expertise way beyond the current requirement of the FCC General Radio Operator's License, the GROL,
Yep.
which doesn't show anything really. Doesn't
Yep.
show you that you know anything really when it comes to BDAs. So we think it's a right step in the direction to make sure that people have some qualifications that make sense.
Okay.
Yeah.
And so one other thing I wanted to touch on is just IWCE in March. You're going to be, tell us a little bit about your class that you're doing
Yeah.
there. You can go ahead and talk about what you're going to be doing, because I'm sure a lot of people want to know what you're going to be up to then.
Yeah. So actually, I've been in RF for a long time, but I've never been to an IWCE for whatever reason. Never. And so this will be my first one.
Oh.
It's in March in Orlando, 2020. And so not only is it my first one, but I did submit a session and it got accepted. So we'll be doing it. And of course, you might have guessed the session is on Uplink. And specifically is if you don't have access to the tower, how do you do uplink optimization? How do you make sure the signal getting to the tower is not too weak and not too strong? And how can you do your best guess to know where it's at? And to be honest, I mean, there is no, since we can't measurement, we really are taking educated guesses. But the talks about how to make a better educated guess, more so than just the spreadsheet. And it's going to be a combination of measuring, doing the link budget on the downlink, which we can do.
Mm-hmm.
We can do all day long. And we'll just start there and assume that the uplink is similar. It's not going to be exact, but we're going to use audio testing. So, but DAQ, or delivered audio quality, where what we're going to do is we're going to take the antenna off of the walkie-talkie and insert between the antenna and the walkie-talkie a variable attenuator.
Ooh.
And what we can do is that we can just start adding attenuation until the system breaks.
Yeah. Okay.
And at that point, we'll double check to make sure that that level makes sense. And then we can start taking attenuation away until we have a margin of safety, which is something else I like to talk about. We don't want the system just to work. We want to make sure that if it works today under the best conditions, it'll work tomorrow under the worst conditions. So we need some margin of safety in there. So what we're going to do is do some measurements, do some experimentation, and make sure that the levels are correct.
Okay.
And so
how do I register for that class for a listener who wants to know?
Hey, you think I would know? Yeah. So IWCE has its own website. I would go there, and actually the last person to know. Yeah.
Is it free, or do they have to pay?
No, I'm pretty sure that to get in you need to pay.
You got to pay. Okay. Well, I know to get in you got to pay, but is the class sort of like free with? You're not sure yet.
Oh, yeah. There's hundreds of classes, and I think.
Oh, really? Okay, great.
Yeah.
So this is
you might want to.
You can take.
Yeah. Yeah. If you go to the IWCE, they have a list of the speakers and classes, and I was overwhelmed by how many things are happening there.
Okay.
My particular class hasn't been scheduled yet, so I'm sure that when my class is happening, there's probably 10 other ones at the same time.
Yeah.
So you probably get to pick and choose where you want to be, is my guess.
Cool. Yeah. And thank you for joining us at DAS Talk. And where can everybody follow you on social media and get to know you more, and also join some of your classes that you're teaching?
Yeah, so I only do LinkedIn, no
Okay.
Facebook, no Twitter, or X, whatever you want to call it. So LinkedIn is what it is, and just look me up. It's Tom Warfield, Warfield, and I work for Fiveplex Honeywell. And every time I teach a class, which is about every other week, I'll post something, and I'll do something stupid. Like I try to come up with fun facts about the town that I'm in,
Cool.
and
It's
so
fun.
you can follow it there. And a lot of my classes are for Honeywell Fiveplex people only, but every once in a while we do have AHJ or fire marshal or anybody that wants to come in. And the next one is not until February. We're actually going to have it at the Honeywell headquarters in Charlotte. And let me tell you, it's an impressive building.
That's going to be fun.
Yeah, you look out the building and there's the Carolina Panthers football stadium. You're looking right down into the field from it.
Oh, really?
So if you're only going to go one class, that's the one.
That's the
That's the
Yeah.
one.
yeah,
Yeah.
that sounds good. Awesome.
Yeah. So that would be you could message me and I could tell you more details about that class
Okay,
Awesome.
I do.
through LinkedIn. Yeah.
Yep, LinkedIn is the way to go. Okay.
Well, thank you for
Yeah.
your time, Tom. Peter, thank you
Thank
as
you.
always. There we go.
All right. Good
All
job.
right. Well, thanks for having me, and I'm looking forward to all the other. You said there's 8 or 9, 10 guests that you're going to have, so I'm really looking forward to seeing that.
Absolutely.
Awesome, Tom. Thank you very much.
Thank you.
All right. Thanks.
Desk Talk by Gamma, keeping you connected and protected.